So hello and welcome everyone. Welcome to another video from pynetlabs. So in today's video, we are generally going to discuss something about GRE tunnels. Okay. So in network, tunnels are a very big part. Okay. So basically, tunnels allow us to connect to any remote site. Okay. And this tunnel, when you do establish tunnel between 2 points, so what it does, it allows us to connect to the remote site directly and privately. Okay, so it kind of like allows you a direct connection and also a private connection. Okay, so say if I have like site one somewhere here and say I need to connect my site one with site two over here, and these two sites might be separated by a huge distance, and we don't have the means to run a cable all the way from site one to site two. So what I'm going to do, I am basically relying on my ISP. So I'm asking my ISP to provide me a connection towards my site. But as you know, ISP is kind of like a public source, so there are high chances like some another organization, let's say ABC, or say someone like XYZ, might also be using this very same ISP. Okay, and once this ISP is distributed, or when there are multiple resources or multiple entities that are currently being using the same ISP as of you, so there are high chances that your data confidentiality might suffer. So that means there are high chances like someone might try to intercept your data.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
So there are high chances like someone in the network here is kind of like try to intercept your data. They might try to compromise your data. They might try to compromise your data. Or even further, they can also do something that is known as eavesdropping. So they could be listening to your data and you might not be totally aware of it. So these are some of the things when we are actually using a common ISP, or we can say like when we are using public network for communication. Okay, so if I am connecting to my remote site, if I am connecting to my office or something like that, so mostly say my office might be situated at a very distant site, and for me it might not be possible to travel all the way here. So what I did, I might be using my ISP to connect to that very site remotely. Now with the ISP, there is always chance, like there is a chance like someone might be trying to compromise the communication, someone might be trying to listen, someone might be capturing your data. So that happens in public networks. So with the help of tunnel, what you do, you kind of like establish a tunnel between the source and the destination. So here, if I wish to communicate with my site one and site two, so with the help of tunnel, I can establish a two-way connection towards my destination. And this one here is our tunnel. Okay. So there are multiple ways in which we can basically implement tunnel. So today we are actually going to talk about something that is known as GRE. GRE basically stands for generic routing encapsulation. So talking about GRE, GRE is kind of like developed by Cisco. So it was first developed by Cisco, and after that it was being uh, like it was being like distributed as an open source solution. So basically what does here is what happens when you do configure GRE is that it establish a point to point connection. So with the help of GRE, I can establish a point to point connection. Now what I mean by that, so say if I'm on my router number one and say I want to communicate with my router number two, and like we just saw in the previous scenario, like 2 points might be separated by a huge number of devices. And say I might be having like here, let's say some number of routers. Let's say I might be having R3, and let's say I might be having R4, and let's say I might be having R5 here. Okay, so say you want to show or say you want to connect with your destination, but you don't want to highlight all this intermediate connection. So say you don't want your source and destination, either of them, to know that they are traveling 3 or even more routes in order to reach the destination. You just want to show them that these two devices are directly connected to each other. So what you do in this kind of scenario, you can basically establish something like a GRE tunnel. So here I can establish a GRE tunnel, and with the help of GRE tunnel, these 2 points might be able to communicate with each other. Okay, so like I said, it basically can be used to provide a point-to-point connection. Okay, so if you want to connect a point directly with your destination, you can configure GRE. Another thing, it could be somehow used to hide like uh, improper routing decision. So we can say, like, if you haven't thought about the routing very well, so you can basically hide your routing decision, or let's say your routing infrastructure, with the help of GRE. Okay, and it is also used to provide routing for many legacy protocols. So there are quite a lot of protocols still available and still being used in the network, which are considered as non-routable. Let's say something that is known as NetBIOS. So NetBIOS is one of the most commonly known legacy protocol that is generally used to identify the network devices and more. So another example could be something like IPX. Okay, so in this kind of scenario, say these two packets or these two protocols, they cannot be uh, routed by using normal routing method. So in order to do so, what we can do, we can basically create a GRE tunnel between the source and the destination. And let's say if I'm using any sort of legacy protocol, which may not be handled by normal routing or say IP protocol. So what we can do, we can generally create a GRE tunnel from the source and destination. Another implementation of GRE is that you can use it to connect discontinuous OSPF network. So say you just created a network where you have R1, then you might be having R2, then you might be having R3, then you might be having R4, and say at last you might be having R5. And say you might have connected all these routers together in a linear way. Now, when you were actually creating the OSPF, when you were actually defining the OSPF area, you didn't uh, fully thought about your network, and you just created some areas like this. So let's say this is my area 0, and so far here, this is my area 1, and say this whole the up to router number 5, we can consider like this is my area 2. So as you can see, now in a network of this kind of situation, so R1, R2, and R3 might be able to exchange or receive the information from the other router. So basically, they will be receiving the updates and the networks from both area 0 and area 1. But my router number 2, 5, sorry, router number 4, 5 may not be able to actually communicate, because as you can see, like this network or this area is kind of like a discontinuous network because it has no direct link to OSPF area 0. So what you can do, rather than recreating your network, you can basically establish a tunnel. So I can create a tunnel between my router number 1 all the way to my router number 4. Okay, so I can basically establish a GRE tunnel. So even though my networks are totally separated away, so we can still make sure that my area 2 might be able to communicate with my area 0 with the help of GRE. So that is a really short description about the GRE. Okay, so as you might know, like GRE, out of the box, it doesn't supports encryption. Okay, so basically, it doesn't supports the encryption. Okay, so the IP header or the actual payload is encapsulated in GRE header, but the GRE header it doesn't encrypt. So when you do implement the GRE or when you do configure GRE, so just keep in mind like you might be creating a tunnel that might provide you point-to-point connection, but that very tunnel doesn't provide you any sort of encryption. Okay, so the data that you might be sharing here could be easily read by someone if someone tries, but still the GRE has certain advantages, like it provides you the point-to-point connection. With this, you can like hide your routing decision, your routing infrastructure. Okay, and say if you are using any older protocol, legacy protocol, so you can actually communicate even using legacy protocol. You don't have to change your hardware. You don't have to remove that particular protocol. You can still make it use or make it functional with the help of GRE. And say like I just saw just demonstrated you if you have any discontinuous OSPF area. So you can also configure GRE tunnel to connect your discontinuous areas with the area 0. Okay, so that is something we did discuss about. Okay, and one thing that you should always keep in mind is that GRE out of the box doesn't support encryption. So if you want to use encryption, then I would suggest that you have to implement IPsec. So you can use IPsec or GRE with IPsec if you want to implement the security. Okay. And here in GRE, when we are do creating the GRE, so GRE uses something that is known as the tunnel interface, which is kind of like a virtual interface. So when you do when you're going to establish tunneling, you have to create the tunnel interface. Now to help you understand a little better, I have created a somewhat a lab. So if I just go back to our lab here, so this is the lab as you can see. So on the left side, I have site 1, which is AS100, and on the right side, I have my site 2, like the AS100. And in between, I have my ISP network, which is AS200. And on of this router, I have configured my EIGRP. Okay, so I can go to router number 1. So here I am on my first router of site 1 router. So if I just get into the configuration part, so if I run the command show IP route, okay, so you might be able to see that we have some EIGRP routes. So here you can clearly see that I have some EIGRP routes here. Okay, I have done redistribution. And if I just specifically run the command show IP route EIGRP, so here you can see like these are all the routes that I generally use, or these are the routes that I'm receiving from my other side. And the same thing is also applicable on the router number 4. So if I just bring up my fourth router and just go through the same sets of command like show IP route EIGRP. So here you might be able to see like I'm receiving all the um, all the EIGRP routes. Okay, so these all routes are coming from the external network. So let's see. Uh, Now to confirm this thing, what I'm going to do, I'm going on to my VPC 7. So this is my VPC 7, and if I run the command like show IP, so this is the IP address that I'm currently using. And likewise, I also have my VPC 8 here. And if I just go to my VPC 8 and if I run the command like show IP, and here also you can see that this is the IP address that I'm currently being using. So if I try to ping my destination, let's say 192.168.10.1, 10.2, sorry. So you might be able to see that I'm actually able to reach my destination. And with that said, I can also trace the route. So if I run the command like trace all the way to 192.168.10.2, so it will show you all the path or all the routers that is presented in our demonstration here, including the ISP network that I have to travel in order to reach the destination. So here you can see that I'm going through 13.3, that is my router number 3. I'm going through 12.2, that is my router number 2. And at last I'm reaching 11.1, that is my router number 1. And finally, we are reaching to the destination, that is the 10.2. Okay, so basically it is giving away all the information like what all the devices are included in order to reach my destination. But say, let's try to create a GRE tunnel. So I might create a GRE tunnel here. So let me just kind of like add a shape so that we can easily understand the tunnel between our 2 points. So let's say this structure is the tunnel that I'm actually going to use for my communication purpose. Let me just drag it to this side. So just this tunnel interface is going to connect my source and the destination. And when I'm connected to my source and the destination, so I will also show you like how the traceRT command might be functioning. So right now we just saw when we were working on PC number 8. So we can see when I do run the traceRT command, you can see like it generally lists out all the devices, intermediary devices that is responsible for connecting the source and the destination. So let's see. So we don't need to configure anything. I have already done the routing part here. We just need to configure the GRE tunnel. So let's say, let's go to router number 1 here. And in this router, let's say, let me configure tunnel interface. So when you are configuring GRE, so all you need to do is you have to create a virtual tunnel interface. So for creating virtual tunnel interface, all you have to do is run the command interface tunnel. Then followed by it, you can put a number. So I'm using here tunnel 10. It could be anything. There's no necessary that you have to go with the 10. You can pick up any number that you like. And once you're into the tunnel interface, you can configure it like the rest of the interfaces. So we got a message here that says the line protocol on the tunnel interface is down now. So don't get worried about that. We will fix it soon. So I'm going to configure the IP address here. So let's say I would like to use the IP address of something like 100.0.0.1 followed by the subnet mask. Okay, then you can exit from here. And once you do exit, then you can basically have to mention the tunnel source, like which interface is the tunnel source. So when you're mentioning the source here, so you can actually use the interface name. So you can mention like the which interface you are using in order to actually use this tunnel configuration. So tunnel is kind of like an overlay network which works upon your underlay network. So there are like two types of implementation, overlay and underlay. Underlay is your actual physical network that you have established. So here my underlay is from router 1 to router 2, then 3, then router number 4. And in order to connect the router number 1 and router 4 directly, I'm creating a tunnel interface. So that is like overlay. It works upon the underlay network. So when we are configuring the tunnel interface, once you have defined the IP addresses, you need to mention like which is the source, which interface will be acting as the source of the tunnel. So here I would like to mention the gig 0 by 0. You can either go with the gig 0 by 0, okay? And if you don't want to go with the interface, so you can actually go with the IP address as both are correct. But when I'm defining the source, I generally prefer to go for the tunnel, the interface name. So here I have mentioned my tunnel source. And with that, you can mention the tunnel destination as well. Now, when you're mentioning the tunnel destination, make sure that you mention the other router. So I will mention my router number 4's IP address, which is definitely going to be 13 here. Okay. So I was in router number 1. So here my destination is gonna be 13.4. That is my router number 4's IP, and that's it. Okay. So the moment you did mention the tunnel source and the destination, we also received a notification that says my tunnel interface is up. And that's all about it. You can exit from here. You can run the command do show IP interface brief. And you might notice that we have a new tunnel interface with the configured IP. Okay, like we mentioned 100.1. Now I'm done here on my router number 1. Now all I need to do is go to my router number 4 and repeat the same sets of process. So I'm creating tunnel interface 10 here once again. I'm adding the IP as 100.2, okay, followed by the subnet mask. And once you do, then once again, you have to mention the tunnel source. This time again, I'm using the gig 0 by 0 interface. The source for source, I always use the interface name. And for tunnel destination, I'm going to use the remote site's IP address. Now, in this case, since I'm on my router number 4, the remote location or the remote site's IP address is 11.1. Okay, and that's about it. And you can basically exit from here. And here also, as you can see, we did receive the notification that our tunnel interface is up. And I can run the command like do show IP interface brief, and it gives you an output that this is the tunnel interface. Now there is one more thing you need to do. You have to get into your EIGRP 100 and you have to include your tunnels interface or the tunnels network. Okay. And I'm going on my router number 1 as well. And I'm just going to do the same thing. Router EIGRP 100. The network here is 100 00 something, and that's it. Okay, so you might notice that I did receive the notification that says my urgency has changed. Okay, and I'm right now neighbor with my 100.2, and this time I'm using my tunnel interface. Okay, so if you want to confirm, you can run the command to show IP EIGRP neighbors. So you might notice that I am neighbor with 2 or more routers. Let me run this command. So here, as you can see, I'm neighbor with my 11.2 using my physical interface, and I'm neighbor with my 100.2 using my tunnel interface. Okay. So basically, that's how you configure a tunnel interface. Now, just to give you guys a proof here, if I just pull up my router number 8, so here I am on my router number 8, and if I just try to ping, so if I try to ping my destination, let's say 192.168.10.2, so I have no issues here communicating. I can communicate. I'm communicating with my destination in normal way. But if I do the traceat command, so if I run the command like traceat one and the destination's IP address, so now you might notice like it is showing me that I'm directly connected. So it is not showing me the information about all the ISP routers that is in between providing me the connectivity. Okay, so here from my router number 1 or from my PC number 7 or via the router number 1, I'm directly connected to my router number 4, then to the destination. So as you can see, there is no intermediate device mentioned. And that is also available from VPC 7. So if I try to ping here from my VPC 7 192.168.20.2, so you might notice that I'm able to ping here. But if I do a traceat command here, so you might notice like here also it is being showing like I am directly connected to the destination. So basically that's how we create the GRE tunnel. I hope you guys understand the concept. Now, if you have any doubts or if you want a video on some another topic, please let us know in the comments. Okay. So thank you everyone. See you in the next video.